This is bonding video number 3. By the end of this video, you're going to be able to find out the shape and bond angle of a covalent molecule using VSEPR. Before you get started, make sure you have bonding video number 3 worksheet and the VSEPR sheet. Both are available on Edline, but they were also passed out in class. VSEPR stands for valence shell electron pair repulsion theory. Taking a look at this word for word, repulsion, electrons repel each other. They want to move away from each other. They're also going to be existing as pairs in an orbital. And lastly, the electrons that are going to be used to determine bonding and eventually shape are the ones on the very outer energy level, called the valence shell. So what this means overall, electrons on that outer energy level are going to take a shape that allows the electrons to be as far away from each other as possible. When determining the shape, your first step is to determine the Lewis dot diagram. But remember, what you have on your paper is not reality. This is a two-dimensional shape because pieces of paper are 2 dimensions. But in the real world, we have the ability to have a 3-dimensional shape. Not everything is going to be flat. In order to determine the shape, you want to take a look at your molecule and find out how many things are attached to the center. In this case, carbon is the center. We have 1, 2, 3, 4 things attached to the center. So we have 4 atoms bonded to it. Taking a look at our shape sheet, number of atoms bonded to the center. Go down. 4 is only here once. This molecular geometry or shape will be tetrahedral, and it'll have a 109.5-degree bond angle. It will look like this. We will be building these molecules in class on a later date for you to take a look at them. For now, notice that the bond angle is not necessarily what you would predict from your sheet of paper, because this is 2 dimensions, but this allows expansion to all 3 dimensions. Let's try another one. Carbon dioxide up here has 2 atoms bonded to it. So 2 atoms bonded. Taking a look at your sheet, number of atoms bonded, we have 2 here, 2 here, and 2 here. So we need to go to the next step. How many non-bonding electron pairs do we have on the center? So take a look at the center. The center is carbon. There are no pairs here or here. So there's 0 non-bonded electrons. These are also non-bonded, but they do not count because they are not on the center. So we have 0 here. This is 1, it doesn't count. This is 2, it doesn't count. So our shape is linear, and it has a 180-degree bond angle looking like this. So while on the previous example it did not look the same as Lewis dot structure, sometimes, as in the case of this, it will be the same. So every time you have to mentally go through this thinking process to see which case you are on. Okay, taking a look at our next and our last one. In the case of water, something you've done before in biology class, the center atom, oxygen, has 2 things bonded. It also has 2 pairs that are unbonded. As a result, water with the 2 that's bonded, but then the 2 that are not, so this is gone, that is gone, This is good. This is going to have an angular or a bent shape, a bond angle of 104.5. Now you want to be careful because there's angular or bent shapes here and here. It's in two locations. They both look, if you look at it, they both look bent. The difference is how much of a bond angle it has. So while the names are the same, the bond angles are different. You want to be careful not to confuse them. The next thing you want to take a look at is the overall shape. Water has 1, 2, 3, and 4 regions around it where it has electrons that need to spread out. These are called the 4 domains. So as you can see here, domains. These are the regions that you have electrons that need to spread out. There are 4 different ways that you can do this. This one, though, is a mixture of bonds and unshared electron pairs. So domains is just equal to the number of atoms that are bonded plus the non-bonded ones.